Hello everyone, feeling pumped? Let's do this. Hello, my name is Marco Gorelli, here to talk to you about how NumFOCUS is silently bringing pandas, polars, DuckDB, PyArrow and more together here at PyData London 2025. Feeling super pumped. All right, let's do this. Now, I want to be one step ahead of my audience, and whenever I give a presentation about NumFOCUS, there's always someone who brings up the XKCD comic about standards. So before anyone does that, I would now like to present to you the XKCD comic. It's a situation in which there are 14 competing standards. Somebody says, 14? Ridiculous. We need to develop a new universal standard that covers everybody's use cases, and then soon there are 15 competing standards. Now, I was aware of this comic when I started the NumFOCUS project. I'm still aware of it. And let's talk then about why I figured we should probably try to address the mess of dataframe APIs anyway. So how today is going to work? I'm going to start with a comparison of life before NumFOCUS and life after NumFOCUS. Then, once we're all hyped up about NumFOCUS, going to have a little crash course about how to do things with NumFOCUS. We'll then talk about some more advanced concepts like backwards compatibility policy, SQL, as well as next steps, and the community behind the project, and how you, yes, you can get involved. Finally, the last few minutes are going to be split between engaging Q&A and awkward silence. It's entirely up to you what the split is going to be like. If you want to ask, if you want to contribute to the engaging Q&A, raise your hand. If you want to contribute to the awkward silence and the person next to you is raising their hand, then maybe find a way to distract them and prevent them from doing so. Life before NumFOCUS. What was life before this project started? I'd like to show a comparison by looking at the Plotly the Plotly visualization library. So when they published Plotly version 6 earlier this year, they showed what an impact it made for plotting different kinds of data frames. So plotting a pandas data frame in Plotly version 6 compared to in Plotly version 5 got slightly faster, maybe like 20% faster, 10% faster, depending on the kind of plot. But we see that plotting a polars data frame often got 10 times faster, 3 times faster, and PyArrow also got similarly faster. What happened? Well, the answer is that NumFOCUS happened. NumFOCUS is a lightweight compatibility layer between data frame libraries. I try to usually pitch it as a tool for tool builders, and it gives you a single API with which you can support multiple tools. And to my surprise, it's actually being used by some major projects such as Altair, Bouquet, Marimo, Plotly, Shiny, and others. I make a big deal out of the fact that it has 0 dependencies, and I'll tell you why I make a big deal out of that later, as well as its stable API and the strong static typing guarantees that we make. Now, before NumFOCUS came on the block, it was common to see data science libraries which would claim to support multiple different kinds of inputs. And what they meant by that was usually that, regardless of what the user started with, they would shoehorn it into a pandas data frame and then continue with their pandas logic. Now, there's nothing wrong with using pandas. I'm just angry with forcing everyone to use pandas, because it's a missed opportunity. If you force everyone to use pandas, then effectively you give up on the benefits of lazy execution. You give up on the benefits of GPU acceleration. You introduce some extra heavy dependencies like PyArrow, and pandas itself. It should be possible to do better, and the NumFOCUS solution to this is meet the user where they are. So if the user starts with pandas, do everything using pandas and give them pandas back. If the user starts with polars, do everything using polars and give them polars back. Similarly with PyArrow, DuckDB, and more. Now, it is possible to do this yourself without using NumFOCUS by using many different if-then statements to handle the different kinds of inputs. In fact, this is a simplified version of what it would look like, because even within the pandas block, you would probably have to have a sub-block for pandas version 1, then another one for pandas 2, then another one for the accidental bug that crept in between pandas 2.1.4 and 2.1.5, and similarly for other libraries. It's a bit of a headache, so instead of giving yourself a headache, accept the fact that we gave ourselves a headache and use narwhals.from native. Now, I make a big deal out of dependencies because I'm sure that a lot of us have experienced what's informally known as dependency hell, where you cannot upgrade one package because another package depends on another package, and somehow, somewhere, someone has put an upper bound on something, someone else has got a lower bound on something, and all of a sudden you've just got a messed up environment you can't upgrade. Another issue is that sometimes you just can't even upgrade your version of Python because there's one package which is not supported on a new version of Python, and all it takes is one thing in your chain to not support the new version of Python, and if it's a required dependency, then everything cannot be upgraded. So with Narwhals, we make a very big deal out of it being zero dependencies. I don't even let people introduce typing extensions as a dependency. It's just pure Python, extremely lightweight, no compiled code whatsoever. We also really care about the developer experience, and Narwhals is fully statically typed, meaning that when you're trying to develop code using Narwhals, you get very helpful annotation. Yeah, the autocomplete experience is made very smooth thanks to static typing and what modern editors do with type hints. I'll also say more about the stable API promises because I think that deserves its own slide, so we'll get to that later. So now that we're all hyped up about Narwhals, let's go on a little crash course and learn how to use it. So if you want to write a dataframe agnostic function using Narwhals, there are 3 simple steps you need to follow. So step 1, you're going to write from native on the user's input. Like the user passes you something in, it could be pandas, it could be polars, could be DuckDB, it could be any other major dataframe library, and you're going to call from native on it. Then step 2 is you're going to express your logic using the Narwhals API. Anyone who's a fan of polars will recognize this as being essentially the polars API. So Narwhals is just a strict subset of essential functionality taken from the polars API. And then finally, when you're done expressing your logic, you return the object to the user in its native class by calling .toNative. If you define a function like this, then it is dataframe agnostic. For example, you can pass a pandas dataframe in, and you'll see that you get a pandas dataframe out. You can pass a polars dataframe in, and you get a polars dataframe out. Similarly with DuckDB and with others. In terms of what's supported, anything that's considered, let's say, a fundamental dataframe operation should be in there. Let's say string operations, uppercasing, lowercasing, contains, ends with, head, len chars, replace, slice, split. Similarly for temporal operations, a day of the month, day of the year, converting dates to strings, strings to dates, different components, as well as joins. Got different kinds of joins, so I'd now like to read them out, and when you hear your favorite join kind being called out, then please give us a big cheer. So left join. Yay. All right. Outer join. Yay. Okay, inner. Semi. So what? Why is semi so underappreciated? Semi is like it's like a filter on steroids. It lets you like take 2 data frames and only keep rows from one where there's some value from a column which appears in a column from a different data frame. It's really cool. Look it up. It's not something that polars invented. It's a concept from SQL, and I really wish they got more attention. Anyway, if we didn't get much of a cheer for semi-join, I don't think we're going to get much of a cheer for anti-join either, right? Yeah. Okay. Was it the same person who cheered for semi? Probably. And then finally, another underappreciated one, as of join. Yeah. All right, got a few but very devoted fans. It's like, yeah. There's, yeah. I mean, I feel like, Left is like some mainstream band that everyone knows and appreciates, and then Join As Of is like some obscure math rock Japanese band that someone really loves, but most people haven't heard of. Having said that, Japanese math rock is pretty cool. I do recommend that people check it out. Okay, you might have noticed that there's no right join. Nobody's requested it yet, and I'm curious to see how far we can go before somebody puts up a feature request asking us to do right joins. Now, in Narwhals, we really care about letting you express yourself. This is a topic on which Polars and Dr. Dre really agree that it's important. So instead of writing things in a Polars style where you repeat data frame names multiple times and you use square brackets and use series, we instead use expressions. Expressions are kind of like inherently lazy functions, so they're reusable, they allow for more optimizations, and in my opinion, they're more readable. The last one is an opinion rather than a fact, but, well, if you start a library, you're free to follow whatever opinion you have. So that's why we've ended up with expressions instead of series in Narwhals. Now, let's talk about laziness, very important concept. Now, we can broadly categorize data frames into two classes, eager and lazy. Now, eager ones, we assume that data is all in memory. So there's some examples of this are pandas, Polar's data frame, PyArrow table, cuDF data frame. We have other kinds of libraries which are purely lazy, so they defer execution and only execute things when you tell them that you really want the answers. This allows for some nice optimizations and for processing data that's larger than whatever memory you've got available. Polar's actually lands in both because they allow you for both eager and lazy execution. DuckDB is purely lazy, Spark is lazy, Dask is lazy. But the main distinction that we care about in Narwhals is row order. So eager data frames we assume to be in memory and so to have a defined row order. Like it's totally well defined to say to do an operation in the order that the rows appear. Whereas for lazy frames, we make no assumption about row order. In fact, we say that row order is undefined. So what's the consequence of this? How do we do order-dependent operations if row order is undefined? Well, let's look at an example of an order-dependent operation, and that is the humble cumulative sum. In a cumulative sum, you progressively sum values from a sequence in the order in which they appear. So for example, if you've got the values 1, 4, 2, 5, then a cumulative sum would give you 1, then 1 plus 4 is 5, 5 plus 2 is 7, and then 7 plus 5 is 12. In an eager context, this is very straightforward to write. You just write dot cumulative sum, and the cumulative sum happens in the order that the values appear. But what about in the lazy context? We've got something order-dependent but undefined row order. So how do we do this? Do we just not support this in Narwhals? Well, the answer is we again leverage what Polars gives us, and so we force you to specify an order. In this case, we've got a column called date, which happens to order our data frame. So if we want the cumulative sum to happen in that order, we just have to follow cumulative sum with over order by date, and then Narwhals allows us to do it. This might feel like a restriction, but this is a restriction that allows freedom. It's a restriction that brings you portability, as now you've got a data frame agnostic function which does not make assumptions about the engine or about row order, and so can be executed on PySpark, on DuckDB, and on other lazy-only engines. This is also totally portable to Polars. We haven't invented anything new with the syntax here. Like if you were to replace NW with PL and run this in Polars, this is valid Polars syntax. Now, an unexpected feature of Narwhals is SQL support. We did not set out with making a Polars to SQL transpiler, but because Narwhals supports several input libraries, including SQL Frame and IBIS and DuckDB, it means that if you've got some Polars code like the following and you want to translate it to SQL, then it becomes a one-liner to do this using Narwhals. Now, I started off using Narwhals to try to solve other people's problems, but when we noticed this, I felt like, cool, this is finally solving a problem that I have, because I like SQL. I really like reading SQL, but I'm just bad at writing it. Like, I just forget things, and then I get a mysterious syntax error because, I don't know, unexpected symbol close to over, and I don't know how to debug that. But by writing Polars code, I can get SQL out of it the other end. Pretty happy with that. Now, I said I'd talk about backwards compatibility, so let's go a bit deeper into that, as I feel like it's something that's underappreciated in our space. Now, sometimes you write a library and you realize that something is bad and things need to change. And if you change things, you're going to annoy people. So what do? You could just never change, but then maybe this means that your users start with a bad user experience and then they keep having that bad user experience. It also means that bad design decisions might block new features. So never changing, let's all agree, can be bad. So the solution that people often come up with is to go through deprecation cycles, which in theory work like this. So today, you decide that your function is bad. Tomorrow, you mark it as deprecated and you issue a warning telling people not to use it. And then the next year, you remove it. Now, in theory, wonderful. Sounds like it should work. Sounds like as long as everyone listens to warnings and follows the rules, then there's not going to be any issues. But in practice, that's just not how humans work. I think we've all experienced something like this, where we just get something, CI is green, passing, we then add it to our backlog, and then the PM never considers it high priority enough that it ever can get addressed, and at some point our pipeline breaks. Not blaming anyone for this, I've done it as well. Also, when we're building software on top of software on top of software on top of software, as a lot of the open source stack is, then if something far down makes a deprecation, then that means everything above it also needs to release new versions that are compatible with that deprecation, and it becomes really hard for users to keep everything in sync. So in summary, yeah, deprecations are bad, and never changing is also bad. So what can we do instead? Surely it should be possible to do better, right? And I think Rust has a nice solution called additions. So the way we do this in Narwhals is by having a narwhals.stable, not that kind of stable, API. So you can use Narwhals in two ways. Either import Narwhals as NW, and I insist on using a two-letter acronym because that is the law in data science. Everything must be imported as a two-letter acronym. And in that namespace, we might make deprecations. Sorry. We've then got this other API, narwhals.stable.v1, and there, the promise we make is code you've written today is going to keep on working 10 years from now. There, we just don't deprecate things. Like whatever bad design decision we make, well, we're stuck with it. And this has allowed us to change things in the main Narwhals namespace, which have had no effect on Altair, Plotly, or Marimo users, because we insisted that when those libraries adopted Narwhals, they used the stable API. So who's behind Narwhals? I'm somewhat embarrassed to admit that I started the project on Valentine's Day in 2024. And I find it amusing to look through the commit history because I started with WIP, and then I thought, yeah, looks like we're getting there, but I wasn't really sure. So hacked on it for a bit longer, and then I got really excited and wrote, yeah, getting there with 3 exclamation marks. Presumably at that point I started enforcing pull requests rather than just making commits and pushing everything to the main branch. But this is how the project started. And to my great surprise, people started using it a lot sooner than I was really expecting. Like within a few months, it was used by Scikit-Lego, then by Altair, then Plotly, then Bokeh, Marimo. And, but anyway, throughout all of this, the project remains community-driven. There's no Narwhals company, there's no Narwhals product. I mean, as far as I'm concerned, the fact that it's solving problems and people are using it is everything I could really have asked from it. I'm very grateful to my employer, who's providing me with some unfunded time to develop it, just because they're happy about the impact it's having. And there's no monetization strategy behind them for it, so I think this is very kind, and the world would be a better place if more companies funded open source software. It's not a one-person project by any stretch of the imagination. We've already had contributions from over 100 unique people, and there's a very active community. There's regular contributors and maintainers. We have regular syncs, which are open to everyone. You can all join. On the README, there's details about when our syncs happen, as well as a Discord server, so you can get involved, so long as you respect the code of conduct and the Zen of Narwhals. So PEP 20 introduces the Zen of Python, which contains one line which I don't particularly like, which is there should be one and preferably only one way of doing things. Like Python does not follow that, no Python library follows that, and it's often used as an excuse from library maintainers to deprecate things without much of a clear benefit. So I figured we need a different Zen. Got the Zen of Narwhals, which, yeah, you can read in your own time by doing pip install narwhals and then from narwhals import this. So what plans do we have? I've talked about narwhals.stable.v1, and I'd really like to get to narwhals.stable.v2. And hopefully this can be the V that just stays stable indefinitely. Maybe in 10 years' time, we'll correct some further bad decisions and get to V3, but I'd really like V2 to be the good one. I'd like to support extra backends, so Daft looks like it's pretty close to being ready. Maybe Data Fusion, I don't know. And finally, I really like Polar's expressions, just in case that wasn't abundantly clear. So I'd like to make even more things expressified and feel closer to the Polar's experience. And would also like to get Narwhals into more libraries, like to secretly infiltrate the rest of the ecosystem. Not gonna Giatan anyone, don't worry. But I do want to see the data science ecosystem become more data frame agnostic. So in conclusion, what have we talked about today? So we've talked about how Narwhals is a tool for tool builders. It's widely adopted in the data ecosystem and is used by Altair, Plotly, Marimo, and more. It supports pandas, PyArrow, Polars, PySpark, DuckDB, and there's more coming on the horizon. And Narwhals allows you to write reusable functions which are data frame agnostic, which follow the pattern of data frame X in, data frame X out. I hope that with this I've given you a nice introduction to Narwhals and what problems it solves. And I'd now like to open up the floor to an engaging Q&A, so long as nobody asks about XKCD 927. Thank you, everybody. All right, 22 minutes. Do I have liberty to choose? Okay, you're going. Go ahead.
Sorry. Is there a wrapper for narwhalifying the functions, like opening and loading? And...
Oh, right, like a decorator.
Yeah.
Yes, there is a decorator available. It's called Narwhalify. And however, my issue with the decorators is that they don't preserve static typing as well as just using plain functions. But I realize that my opinions on static typing are a lot stronger than those of a lot of people in the Python ecosystem. So if you don't like static typing quite as much as I do, then maybe the decorator will be good enough for you. Good one, cool. I saw a few hands come up here, so.
I didn't get the zero dependency part. Is it built in Rust?
There's nothing in Rust, it's all pure Python. It's that there is zero required dependencies. So if the user passes in a pandas data frame, then we use pandas, but we know that we can use pandas because if the user passed in a pandas data frame, then they must already have had pandas installed. So we do use other libraries, but we only ever use what the user is already passing in.
Thank you, that was really funny.
Sure.
Good joke. So you said that it was a tool builders. I can see the appeal of that for tool builders. Is that the main area you're targeting, or is there application within a business logic state or within a sort of I'm doing data science in my business state?
Yeah, I mean, it's a bit like how my grandfather kind of likes listening to Taylor Swift. I think he's probably not the target audience, but he's still allowed to enjoy it. So similarly, the target audience for Narwhals is tool builders, but I think there is a space for people working within companies wanting to write functions which are broadly available to different teams which are using different tools, as well as people wanting to write their logic in such a way that it avoids lock-in to any particular data frame library. Thanks for the question and nice haircut.
Hi. Do you support user-defined functions?
User-defined functions? No. Sorry for the disappointing answer, but no, we just stick to fundamental operations. And I think the Polar's API is flexible enough that you should be able to do most things that you'd like to do. But yeah, really customized things, I think at that point, different libraries do it differently. So you're better off choosing some particular library to do everything in, and then having the full luxury galore experience using that library, rather than trying to make it data frame agnostic.
Firstly, thanks very much for the very humorous and very informative talk. Can I ask, have you run some benchmarks? What sort of performance hits do you get for the added kind of visualization?
Yeah, that's a great question. I think there was Plotly showed what happened before versus after narwhalification. So it was expected that for polars and PyArrow things would get faster, because like the overhead of going through narwhals, we expected would be less than the overhead of going through pandas. We were pleasantly surprised to see that things got a bit faster even for pandas. And the reason is that we don't do anything expensive in narwhals. Narwhals is literally just translating between different APIs. So all of the expensive compute happens in the native libraries. And in particular, this means that we can try to make some good decisions on behalf of the user. And pandas is a bit tricky to use properly, to put it mildly. And within narwhals, we can avoid redundant copies and redundant reset indexes, which, I'm sure we've all done reset index without thinking about it twice, but did you know that it copies all your data before pandas 3 and without copy on write enabled? No, you probably didn't. And that's a potential performance hit. Side note, we also accidentally fixed a really old bug in Plotly when they narwhalified, because, just for free. And that's because nobody understands how the pandas index works.
Thank you.
Thanks for the question. All right. Nice to see such an engaged audience. This is fun.
Can you do people of say one format and switch to another framework?
Yeah, so we do have functions like there's 2 polars, 2 pandas, 2 PyArrow. And if you're starting with something eager, you can also do like .lazy DuckDB or .lazy Dask and so on. So it's, kind of convenient way to switch between frameworks. But then I think that's more useful to people just using it to do their own analyses. If you're building a tool for users, then maybe try to stick to what they're providing and only switch when you really have to.
Hello.
Hey.
Thank you very much. Obviously, you had a bit of success with your library being adopted and all this sort of stuff. Were there any growth hacks or anything you used to get the buzz, or was it just you just hit a good spot everyone wanted their novels?
Some growth hacks, yeah, that's a good one. So I think open source is arguably more of a social game than a technical one. And I'd spent 4 years on the pandas core development team and was already on the polars development team. And some people from the open source community picked up on what I was doing. And I think that the fact that they might have already known me meant that they could trust my library in a way that they might not have trusted a complete newcomer to the scene. It's a bit sad that things work like this a lot based on personal trust, but I'm not complaining. It kind of worked to my advantage, and that's the closest that we got to growth hacking. Love the question, though. There's one question I was expecting to get, which we haven't got yet, so curious to see if we can end the Q&A without it happening. Let's see if this breaks my prediction.
Why did you call it narwhals?
That's a great question. I didn't want to call it narwhals. I wanted to call it puffins, because I wanted an animal, and then I thought, well, people do import polars as PL, maybe we can do import puffins as PF. But unfortunately, puffins was taken, and when I emailed the person who wrote that library asking, hey, you published this library 10 years ago and it's not received any updates, would you mind giving me the name? This person replied saying, no, sorry, I still use it, so you can't have it. So I looked at the Wikipedia list of Arctic animals, and narwhals was there. And I thought, I can't call it narwhals. People will think of that Mr. Weeble song about narwhals swimming in the ocean causing a commotion. But I didn't like any of the other names, so narwhals it was. And now I think that the reference to the Mr. Weeble song is one of the funnest part of the projects. So that's a comprehensive answer to the history behind the name. Great question. You were talking about the song. Could have been? Porpoise! Oh my gosh, I need to start the project again.
Could you say a bit about how the SQL translation works? It reminded me a bit of the dplyr in R universe. How does it work in backend?
Ah, right, yeah. Yeah. So we don't do it. So what we do is we support DuckDB through its Python API, and we support PySpark through its Python API. And when you do that, then these tools have their own way of generating SQL. Sorry if that's disappointing and you were expecting me to be a SQL transpiling expert, but that's what we do.
Sorry, probably related to that question. I was a bit confused about IBIS.
Yes!
So I guess you just replied.
Okay. So, extra slides. How does Narwhals differ from IBIS? So IBIS, for anyone not familiar, is a Pythonic front end to SQL engines and polars. And yeah, people used to compare them a lot, but actually we figured, we should be able to support IBIS as one of our inputs. So yeah, as of Narwhals 1.39, I believe, Narwhals does in fact support IBIS as an input. So yeah, no need to see them in competition. If you like using IBIS, then any data frame agnostic function you define using Narwhals will also accept IBIS table. All right, the questions keep coming. This is great.
So does this mean you can hook it up to things like Snowflake, Trino?
Yeah, it's not something I've done, but with IBIS you can set the backend to be something like Snowflake or Trino. So then you could just do your logic using Narwhals, and then when it comes to executing, then yeah, it should all happen according to the backend you've set in IBIS. So they have to do the difficult work of hooking up to those databases, and we just translate APIs.
How future-proof Narwhals to any hypothetical view like these data frame libraries like about how to work with technical into they update Narwhals to support, say, the next Narwhals academy or like that may end up using it in 10 years' time.
Sure, so I think the question was how future-proof is Narwhals against changes in data frame libraries. We test against the nightly builds of all of the data frames that we support. So we try to be one step ahead of people in terms of breaking changes that they might have, so that if they make a breaking change, we should be able to be compatible with that before the new version comes out. All right, Matt, ex-colleague of mine. Hey.
How hard is it to actually wrap a new library? How similar are pandas and polars and all these libraries together? I'm interested in how much work it is to make all these statements. Is it the same kind of code, or is it actually quite different? Trying to have these atomic kind of methods and all?
It's somewhat different. So we've got different subfolders for each kind of API that we support. The SQL-like ones are kind of similar. So something like DuckDB and PySpark, they can share a lot of things together. And pandas and PyArrow, they don't have the concept of expressions. So for those, we need to do a bit of extra work to translate the expressions API to them. But it's feasible. Like this IBIS support PR, there was one extremely brave and extremely motivated contributor who came in with 51 files changed and 2,000 lines. Like all of this he just did by himself and just comes all along with this near perfect PR. Like this is what I love about open source. This kind of thing just happens. So I think it is possible for you to contribute your own backend if that's what you're interested in doing.
Thanks.
Really making you walk from one end to the other of the room.
Do you ever plan to support AstroPy tables, or they're just too far out?
AstroPy tables. I didn't know that they were a thing. But yeah, sure. In for a penny, in for a pound. Let's support AstroPy tables. If you have a use case for them, then please do open an issue on our GitHub, and we can work towards it. All right. Well.
Great. Then we have some time for questions. Slightly question, but can the performance improve by-narwhalifying a library for pandas functionality to be used to show incorrect use or like improper use of their API. We were saying that the performance gain for pandas were not expected, and that kind of shows that someone used their API improperly.
Yeah, totally. I mean, that's the story that happened in Plotly as well, where some historic bugs accidentally got fixed by narwhalifying because, yeah, to repeat what I said earlier about the pandas index, nobody understands how it works. It just behaves very counterintuitively. And unless your name is James Powell, then you don't know how to use it. So I think using an abstraction layer which doesn't make use of the index can lead you to writing more robust pandas code. So yeah, thanks for the question. All right, I think we're all questioned out. And thanks everyone for attending. This was a lot of fun. Thanks for the engaging Q&A. Now please go out and write something data frame agnostic. Hasta luego.